Kia ora, year 12 and 13. This is another video on conics, and this one is looking at the idea of a locus. Now, a locus is a set of points, and the best way to get the hang of it is to do an example. So here we're going to find the locus for a point xy, which I should have called P, and this point P moves in a particular way. The sum of the distance from point P to a focus point at -3, 0, and another focus point, which we'll call F2, at +3 and 0. So the sum of those is equal to 10. So those of you who were in class today will recognise this as the problem that we did while lots of people were off doing their physics assessment. And what we're trying to get here is basically an equation that links x's and y's together, that traces out the path of this point. So it's worth making sure that you've got that diagram in your book, because we're going to be using it when we get into this. If you've already had a look at the general proof for the formula of an ellipse, and you've managed to follow that one, then this is a much easier version of that, because this has got two specific points and a total distance of 10. Okay, so let's start off by saying, well, what do we know about the distance of each of those points? And it just comes back to Pythagoras, like so many things in year 13. So on the next slide, we're going to start working out what we can say about the path of that point P. Right, so we can write this: from P to F1 plus the distance from P to F2 is equal to 10. Now, F1 was at -3, 0, and xy is my point P. F2 was at 3, 0, and my point is xy. So by Pythagoras, I can say this, that x minus -3 squared plus y squared plus x minus 3 squared plus y squared is equal to 10. Right, so that is coming purely from Pythagoras. Here's my xy, and here's my -3, 0. So that horizontal distance is going to be x plus 3. So we can start simplifying this, and we'll get this: x plus 3 squared plus y squared plus x minus 3 squared plus y squared. That all equals 10. Now, that's not so nice. We're going to try and get a nice expression for x and y. So we'll do a bit of rearranging. I'm going to leave this one here. So this equals 10 minus this. Right. The next thing I'm going to do is I'm going to get rid of the square root on this side by squaring. Whoops, I don't know what's happened there. So if I square both sides, I can get rid of the square root over here, but I'm not going to get rid of the square root over here. Okay, I'm going to have a bit of a mess over here. So as usual, as long as we do the same thing to both sides of the equation, nothing will go wrong. So on this side, I'll have x plus 3 squared plus y squared equals, and over here I'm going to have 10 minus this squared. So we need to work on that side. Change colours again. So we're going to have 100 minus 20 root of that plus, now when I square this, I won't have a square root sign anymore, so plus x minus 3 squared plus y squared. So that's looking a bit better, and we can immediately see that we can knock off the y squared, so we subtract y squared from both sides, and now I'm going to expand out. I get x squared plus 6x plus 9 equals 100 minus 20 root of this thing plus x squared minus 6x plus 9. So again, I can subtract some terms from both sides, those, and now I'm going to add the negative 6x on. So I end up with 12x equals 100 minus 20 times that. Okay, so I'm still trying to get rid of this pesky square root sign. I'm going to rearrange this. I'll write it in the following way. So 20 times the square root thing equals 100 minus 12x. Right, so some easy rearranging. Right, I'm going to pop a new slide in. Those of you who are feeling confident can probably get right through to an expression with that looks pretty straightforward. So you could pause the video here and keep on going. Otherwise I'll go through step by step. Okay, so we've got this. Now I'm trying to remember what we have. I think we have 10 minus 12x. No, we don't. We have 100 minus 12x. Right, I'm going to square both sides. So we have 400 times x minus 3 squared plus y squared. And that's going to equal 4 zeros, 10,000, minus 2 times 100 times 12x plus 12x squared. That's just expanding the quadratic. So we'll clean up this side first. So 10,000 minus 2,400x plus 144x squared. Now, on this side, we've got 400 times x squared minus 6x plus 9 plus y squared. So let's expand that out now. So we're going to have 400 x squared minus 2400x plus 3600 plus 400 y squared equals 10,000. We're nearly there. Be patient. Right, and again we can see the really cool thing that we can see here is that we've got matching x terms here. So we can add those to both sides. So they go. Right, now we just need to combine like terms. So let's see what we're left with. Well, we've got 400x squared here, and we've got 144x squared here. So my strategy here is going to be to get constants on one side and x's and y's on the other. So here comes the new slide. So when I subtract, I'm going to get 256x squared plus 400y squared. Now let's look at what we've got on the other side. Well, I've got 10,000 minus 3,600. So 256x squared plus 400y squared is equal to 6,400. Now I'm going to divide both sides through by 6,400 and we'll see what we get. So here we get x squared divided by 25 plus y squared divided by 16 is equal to 1. Right, now this is the general form, or not the general form, but a form of an ellipse, which is given to us from these two foci. Right, we'll do this in class. Some of us did it already. If we have a piece of string that is a fixed length of 10, we can look at how can I trace out the path of that point P, X, Y, such that if I fix these 2 points, F1 and F2, and I trace out what happens to the string, well, it turns out, so there's my ellipse, it turns out to have this beautiful equation. And you can see in here some X and Y intercepts. Right? You can't see your foci on the ellipse because they are inside the ellipse. Right? But what you can see here is that when x is equal to 5, then this is 1, so this here must be 0. And when x is negative 5, y must be 0. Similarly, if I have y equals 4, then I have this term being 16 over 16, which is 1. So this one over here must be 0. And the same thing happens at y equals negative 4 and x equals 0. Okay, so that's the idea of a locus, and that is a proof for that particular piece of string and that example of how that locus turns out to fit with this ellipse equation. Right, you won't be required to do that in any assessment, but I think it helps with understanding where the equation came from. Alright, thanks for your patience. Hope you enjoyed that. There'll be some more ellipse videos coming soon.